In this video, we will talk about OSPF optimization. In OSPF, route summarization can be done on the ABR router or on the ASBR router. Okay, so ABR summarization is used by ABRs to summarize routes between different OSPF areas. So this helps in reducing the number of routes exchanged between areas. On the other hand, ASBR summarization is used by ASBRs to summarize external routes from the other routing protocols before injecting them into the OSPF. So with route summarization, ABRs or ASBRs combine multiple route information into a single route, and ABRs summarize type 3, ASBRs summarize type 5 LSA. So if you have a look into the screen, you are seeing an ABR is sending some of the summary routes to area 0 from area 1. Okay, I have different routers connected to 192.168.10, 20, and 30 segments, and I am summarizing those routes as 192.168.00/16 to area 0 by the help of my ABR router in this example. So what are the benefits of OSPF route summarization? First of all, it helps to reduce routing table size. So by summarizing multiple routes into a single route, the size of the routing table is reduced on the receiver side. Then it decreases the routing information exchange. It reduces the amount of routing information exchanged between routers, which can lower overhead and improve the network performance. And it also improves the convergence by simplifying the routing information, which can lead to faster convergence times. So this is how the configuration looks like. I am using area followed with the area ID. Then I am using the range keyword. Okay, this one is the keyword which is doing the trick. And then I'm typing IP address and the mask. We can perform the route summarization with our ASBR router as well. In this example, I have my router 1 as an ASBR router because it is connected to an external routing domain, which is an EIGRP domain for this example. Okay, if you want to perform a route summarization with my ASBR, the command you need to use is the summary address. Okay, so basically you are going to the OSPF mode by typing router OSPF 100, and then you are defining this summary address configuration. Summary address followed with the IP address and the subnet mask. I mean, this is basically what you are trying to summarize from EIGRP to this OSPF domain. Okay, so as you are seeing in here, I have some networks configured from 192.168.00/24 to 192.168.15.0/24. So I can just configure only one summarization to cover these both routes, and I can send them as a single statement with 192.168.00/255.255.240.0. And we have the OSPF virtual links. OSPF virtual links are used to connect discontiguous OSPF areas through a transit area, typically the backbone area, which is area 0, to maintain OSPF connectivity in a network. So they help to extend the backbone area across non-backbone area. So normally when designing OSPF, each area must be associated with area 0, guys. So a design like in the screen is not possible for OSPF because you are able to see that only area 1 is connected with area 0. So area 2 only has connection with the area 1 but not with area 0. But if areas cannot be connected physically to each other, there should be a solution which can be used temporarily until I can connect my area 2 to area 0. Okay, so in such case, the route table of router 3 and router 4 will not be aware of the network connected to Ethernet 0 interface of router 2. So for this kind of scenarios, we need to configure the virtual link between router 3 and router 2. So this is how the configuration looks like. For my router 3, I'm going to the OSPF mode and I am typing area 1 virtual link and the router ID of this router 2. Okay, so pay attention that I am typing it for area 1, not for area 0 for router 3. And I am using the router ID of router 2. Okay, same applies to the router 2 as well. So for router 2, I'm going into the router OSPF 1 and then I'm typing area 1 again. Okay, I am using the area, the one in the middle for router 3 and router 2, which is area 1. Area 1, virtual link, and this time I am assigning the router ID of router 3. Okay, so you can basically use the show IP OSPF virtual links command for verification of this configuration. OSPF stub and totally stub areas are types of OSPF areas that reduce the routing table size and overhead by limiting the types of routes that are advertised within them. Okay, so for example, let's consider a topology like in the screen. If you go ahead and type show IP route for the router 1, for example, you will be able to see a lot of routing information within the router 1's routing table. Okay, that means you will be able to see even the routes coming from this external routing domain, which is the RIP domain, will be shown in the router 1's routing table. But do you think router 1 really needs to know about these external RIP domain routes? I don't think so, buddy, because router 1 has only just one exit point for the other external networks, and this is via this ABR router, which is router 2. The only thing router 1 needs to know about this topology is I should be reaching any other network by the help of my ABR router 2, right? So if you are sending these RIP domain routes to the router 1 routing table, that will only inflate the routing table of the router 1. That's it. Okay, so to overcome this, we have two different methods: OSPF stub area and the OSPF totally stub area. OSPF stub reduces the amount of routing information exchanged in the area, which decreases the size of routing table and reduces the amount of routing protocol traffic. Okay, here in a stub area, external routes, which are the type 5 LSAs from outside the OSPF autonomous systems, are not advertised into the area. So in a stub area, there is no LSA 5. Okay, and when it comes to the OSPF totally stub area, it further reduces the routing overhead. Okay, provides even more reduction in routing information compared to a standard stub area by also filtering internal summary routes. Okay, so in a total stub area, not only the external routes, I mean the type 5 LSAs are excluded, but also type 4 LSAs and the inter-area routes, which are the type 3 LSAs, are excluded as well. So in a totally stub area, there is no LSA 3, 4 or 5. Alright, so how I am doing the configuration for OSPF stub. Okay, so let's have a look to the router 3. Router 3, that is the ABR for this network, right? So one interface belongs to area 0, another interface belonging to area 2, where I will go ahead and configure the stub area. Okay, so in router 3, in OSPF mode, I am typing area 2 and stub. That is it. I'm not configuring anything else to define a stub area with the ABR. Okay, so the other configurations are pretty much basic configuration for interface as well as for the OSPF configuration, but this is defining a stub area, which is area 2 for router 3. I just need to do another configuration for router 4 to define this stub area. Okay, so for router 2, the configuration is, by the way, this will be 100, I think. Router OSPF 100 again. I have my network statement, and the configuration I will type for my router 4 is also area 2 stub. Okay, the same configuration, but pay attention that you need to configure in both router 4 and the router 3. Okay, so this will help us to configure a stub area for area 2. Great, now let's have a look OSPF totally stub area configuration. Again, there is a similar topology. I have my ABR router, which is router 3, and I have my router 4 router in here. Okay, in my ABR, to configure the totally stub area, the configuration I need to do is area 2 stub followed with no summary. Okay, so it will be area 2 stub and no summary, the configuration that I need to do on my ABR. But on my router 4, I am doing this area 2 stub configuration still. That is it. That is the difference. This one is the difference compared with the stub area and totally stub area. Pay attention that the ABR configuration differs, but configuration for router 4 remains same for total stub area as well as the stub area configurations. So we have something called OSPF not so stubby area as well. That is a type of OSPF area designed to allow a more flexible approach to external route distribution compared to a stub area, while still maintaining many of benefits of a stub area. NSSA is particularly useful when you need to introduce external routes into an area, but want to keep the area simpler and reduce the amount of routing information it handles. Okay, so first of all, unlike a stub area, an NSSA can import external routes into the OSPF domain. Okay, and external routes are redistributed into the OSPF domain and are carried as type 7 LSA within the NSSA. Okay, and when external routes are advertised from an NSSA to other OSPF areas, especially to the backbone area, they are translated into type 5 LSAs by the ABR and then propagated as such. So LSA types in NSSA, we have type 1 LSA, which is router LSA advertised within the area. We have type 2 LSA, which is network LSA advertised within the area. And we have type 7 LSAs, which is used to carry external routing information within the NSSA. So lastly, propagating a default route in OSPF that involves advertising a default route 0000 guys into an OSPF area or the OSPF domain. So this is useful for providing a path for packets destined for networks not directly reachable within the OSPF domain, and you can achieve this using the default information originate command as you are seeing on the screen. Alright, we are coming to end of this session, and thank you so much for listening to me.